we are expected to find the exact value of the definite integral. To find the value of the definite integral, we evaluate the integrand first. So we integrate 4e to the 2x. That becomes 4e to the 2x over 2. And then negative 2e to the negative x. We have 2e to the negative x divided by negative 1. And this is evaluated from minus 1 to 2. So the first part here can be simplified to 2e to the 2x plus 2e to the negative x. Now we replace x with 2, and that gives 2e to the 4 plus 2e to the negative 2 minus the antiderivative evaluated at negative 1. So we have 2e to the negative 2 plus 2e, negative x. When x is replaced with negative 1, we just have 2e to the 1. We can just leave it as 2e. And to simplify, we open all the brackets, expand everything. These two cancel off, and we are left with 2e to the 4 minus 2e. Question 2. On the same diagram, we sketch the graph of y equals 3x and y equals modulus of x minus 3. Modulus of x minus 3 is just a V-shaped graph. Y equals 3x is just linear. Okay, let's say we have the xy axis here. To sketch the graph of y equals 3x, y equals 3x passes through the origin. And when x is 1, y is 3. So y equals 3x passes through these 2 points. We just need to sketch a straight line passing through these 2 points. And for the graph, y equals modulus of x minus 3. When x is 3, y is 0. When x is 4, y is 1. So it passes through these points. Since it is perfectly symmetrical, passes through these points as well. Then the modulus function will have a graph like this. Yeah, it may not be too accurate here. That is y equals 3x, and this is y equals modulus of x minus 3. Part B, find the coordinates where the two graphs intersect. From the graph, it appears that the modulus function intersects the linear graph at only one point. When the two graphs intersect, they share the common y coordinate. So over here, modulus of x minus 3 equals 3x. In order to solve this easily, we can square both sides so that the square of x minus 3 equals the square of 3x. That will get rid of the modulus. And expanding the left side, we have x squared minus 6x plus 9. On the right side, we have 9x squared. Moving everything over to the right side and flipping, we have 9x squared minus x squared plus 6x minus 9 equals 0. That is 8x squared plus 6x minus 9 equals 0. This is a trinomial, and it can be factored to 4x minus 3 and 2x plus 3. Solving for x, we set 4x minus 3 to 0, so that x equals 3 over 4. And we set 2x plus 3 equals 0, x equals negative 3 over 2. Now, clearly, this is not possible because they do not intersect. To the left of the y-axis, x equals negative 3 over 2 is somewhere here. They only intersect at this point where x is 3 over 4. So to find the coordinates, we need to find the y coordinates as well. That is just the x coordinate. To find the y coordinates, we sub x equals 3 over 4 into y equals 3x. That will make your life easier. So here 3 times 3 over 4, and that is 9 over 4. Then we say that the point of intersection has coordinates 3/4 and 9/4. Part C, deduce the solution of the inequality so that intersect here at x equals 3 over 4. For the inequality where 3x is less than x modulus of x minus 3, the graph of 3x must be below the graph of the modulus of x minus 3. This is the only part where the graph of 3x is below the graph of the modulus function. So for this case, you see that to the left of 3 over 4, the graph of 3x is below the graph of the modulus of x minus 3. Then over here for part C, the solution to the inequality must be x less than 3 over 4.